So for this week, we're looking at introducing conversational AI. So we're going to talk a little bit about what conversational AI is and sort of some of the different technologies around it. And just as a quick introduction to the idea, and this is sort of the baseline at which we'll be building on as we go throughout this course. Right? So when we talk about conversational AI, there's basically essentially the idea is that we're using artificial intelligence to mimic either written or voice interactions between people and computers. And those can be intermingled, right? So we could be talking about a website that for a travel agency that uses a bot to automatically respond to queries. Or it could be an interactive voice system, like when you call a large company and you ask to speak to someone. Georgian College actually uses this exact same technology. If you were to call the main college line, and instead of trying to remember or know what my extension is, it will ask you, who do you want to talk to? And it will just say, hey, I want to talk to Ross Bigelow, and it would automatically forward you to our extension, or to my extension. Okay. So when we think about conversational AI, there's actually a number of different components, and how these are achieved and how they work vary drastically depending on the application. But when you were to break it down into three different aspects, essentially you have first what's called natural language processing. And this is where you're trying to determine what is the intent of the interaction. In other words, why is this person talking to a computer? What is it they're trying to achieve? Right? Is it a website? Is it a question? Is it you want me to do something with this information? And this is something that we really take for granted as we're talking to people and during natural conversations, right? Even the English language is extremely complicated, and how you phrase and structure communications, and you get into using slang words, it's not something that you can just pre-program every possibility. You really do need to use an artificial intelligence with the parameters where you define the rules for engagement and you specify these are the types of things or queries that I expect to handle. And then once we know the intent of the user, then we want to run probably some machine learning to figure out what is the correct response, right? What is it that the user, like if the user is asking what time is class today, well, you have to know who the user is. You have to know their schedule. And then even from just doing the machine learning piece to figure out how do I pull all these pieces together, you have to finally do a text-to-speech translation. So it's actually a three-step process. We do the natural language processing to figure out what is the user trying to ask. We do some ML, machine learning work, to try to figure out what is the correct response based on what we think the intent is. And then we translate that into a text-to-speech type system. Okay. Any questions around all of that? Does that make sense? So sort of as we go through each slide, I'll pause for a few seconds for you to ask questions, and then we'll move on to the next one. Okay. So you're going to hear about this individual, Alan Turing, a lot. He was the one that first sort of formulated the idea around how do we benchmark or how can we measure the effectiveness of an artificial intelligence system. And really the Turing test is all about, can you essentially fool a person into thinking that they're talking to another human being versus a computer, right? When we think back to some of the earlier systems, going back, I mean, this was 1950, right? This was 70 years ago now that this was sort of formulated. and we sort of saw where computing technology potentially could go. So in the case of, and we're sort of framing this conversation just around conversational AI. So within the framework of conversational AI, we're talking about how well can you interact? How well does your system go through each of these three steps? How well does it determine intent? How does it formulate a correct response? And then also, how well does it speak? Right? A lot of AI systems today, you can tell just by the voice that it wasn't someone, it's not quite natural, right? A lot of these systems have evolved significantly in the last even 5 years, but it is still not quite at the point when you're talking to a conversational AI system users can pretty much tell, well, I'm talking to a machine. But we are getting extremely close in the conversational piece to be able to know that this is a robot, right? Or sorry, not to be able to know this is a robot. I think when we start talking about things like AI robotics and cybernetics, all that type of study, I think we're a little ways away from a AI robot that totally looks and behaves like a human being, but it is coming as well. Okay. Now again, just to sort of show this really isn't a new concept, we have this clip from Star Trek.
Former Governor Codus of Tarsus IV, also known as Codus the Executioner. After that, background on actor Anton Caridian.
Working. Codus the Executioner.
So essentially, you can see even in this response, actually I'm just going to pause that for a second. Right, so obviously there's a storyline here, and they're trying to do some research around finding an individual, right? And essentially, Captain Kirk here's asked the computer, find me what you have about this person and that person.
Prior to 20 years ago.
Photograph Codus. Photograph Caridian. Now photograph both.
So what I find really interesting about this clip is, keep in mind, this is from 1966, right? So a long time ago. The foresight there was in place to recognize that computers would be able to talk to people and do queries and things like that. All the stuff we're talking about in this course. This is an obvious case of facial recognition where, again, due to the storyline here, Captain Kirk's trying to figure out who this individual was, not recognizing, oh, it's the same person. Well, today now, obviously with facial recognition and some of the other systems we have, this would be an automatic. The computer would just sort of figure out, hey, this is the same person, right? He shaved his beard and got a little bit older, but the facial patterns are all the same. So while things are still constantly evolving, I think this is important to reflect on. This idea of talking to computers obviously is not a new concept, right? But we are at a point now where the technology has really matured and we now have this whole internet of data and information that can immediately be accessed and exchanged, and we can pull some information from one database and correlate that with information from another database and essentially leverage all of these together. Okay. Now these are some different AI or conversational systems that you've probably heard of. Many of you have probably used, right? The big two in the mobile space is Siri from Apple, and Google's sort of voice assistant, and that's kind of the same thing that's baked into Android. Google's kind of done a few interesting things with their platform, and it tends to almost go by a whole bunch of different names, right? I mean, we have Google Nest, we have Google Assistant, you have the whole dictation feature in Android. So under the hood, it is all basically the exact same type of system. You have Windows has Cortana, and Amazon has obviously spent a lot of time developing the Alexa platform. And again, when we start talking about the definition for chatbot is kind of blurred. In some ways, this is considered chatbots. I prefer to use the term conversational AI. To me, a chatbot is still sort of that text-only notation, but it seems like a lot of the vendors are using the term chatbot to even refer to these different platforms. But that's, to me, the chatbot still is sort of the whole typing and things like that. Yep, no, absolutely. And I mean, this whole concept of automation and, again, fetching data from different systems, figuring out what the right data is a whole nother specialized kind of application for AI, right? And I mean, that in itself is its own course, for sure. This course, just the conversational technologies, I mean, we could do probably 3 or 4 courses on these stacks and on all these systems as well. So yeah, there's just so many of them. Now, interestingly enough, there's still some struggles there, right? And so this is kind of the screenshot there is kind of a chatbot gone wrong, where it's asking, "Hey, can I help you? Yes, are you able to take refillable bottles into the venue? We don't have any events at the moment. Can I help you with anything else?" So you can see right off the bat what's happened. The AI system has failed to correctly identify the user's intent, right? The question is, are you able to bring water bottles in, right? So those 3 steps that I discussed at the beginning of this lesson, they sound simple, but implementation can actually be extremely difficult. And this is one of the things that I really like about the 2 platforms that we're going to be doing in this course, is they make the intent piece a lot easier to navigate, right? If we were to try and scratch code our own chatbot type system, which absolutely you can do, there's tons of open source examples on GitHub of people that have done this, but it's really easy to not necessarily get the intent correct, right? And when you use things like Alexa or Google Assistant, they've invested millions of dollars into these platforms to essentially capture that, right? I mean, Google's whole business model, the whole reason Google exists, is capturing intent and relaying relevant information, right? Whether that's ads or something that's being searched for, or correlating your email messages, right? And using AI in that form. This is what they specialize in. So this course, I've taken the approach, we will do a little bit around some simple chatbot automation, so you kind of get a feel and a flavor as to how that works. But really the focus is, again, trying to give you real world skills that you can go off and market yourself to a company to say, look, I can build you a Google Assistant app, I can build you an Alexa app. Those are extremely marketable and in-demand skills. So that's really where I want to spend a lot of time in this course focusing on. We could easily spin this course into a course that just focuses on how does the text-to-speech and speech-to-text work, right? Because there's obviously a whole bunch of mathematics behind the scene. There's a whole bunch of algorithms there that people have figured out. How do you decode these messages? How do you translate words coming out of my mouth into a format that the computer can understand. And this is actually what we're going to look at next week at a high level, but we're not going to get down into the weeds around the actual algorithm piece. That's really more what you would see in a master's type program versus what this type of stuff we're going to be doing in this program. Okay, so this is my own definition. This isn't necessarily what the rest of the world thinks. In my mind, I sort of see the chatbots as sort of a dumb version of a conversational AI. They tend to be more of pre-coded, predetermined bots that will respond to specific questions. Right? Now, you could ask the question, yeah, what's the weather like? And you would pre-program that and say, well, go off to the weather network and figure out where the person is and return the temperature, right? That would be sort of a chat bot. Where we start getting into a conversational AI using natural language processing to figure out intent, that is where we start talking about, well, what's the weather right now? Well, now the system would look and it would actually apply some artificial intelligence to say, okay, the current temperature is this, but it's going to rain later today, right? Or it's going to be a storm or something else is going to happen later on. So we're building in a more sophisticated level of intelligence than simply sort of a canned answer, right? So I sort of look at it as a chatbot is almost like an exam, right? Where I ask you, okay, answer this question, and then you answer the question. And then I ask you another question, then you answer another question. And as opposed to taking that natural language processing to figure out the intent, right? And yes, in a lot of ways, some telephone banking could be considered AI. Now, I wouldn't say if you're in a system where you're using the keypad to say enter and do all your transactions, that is more of a pre-programmed bot type system. There really isn't much AI there. The AI piece comes in where a lot of the banking systems now have the natural language processing piece, right? So they will do things and say like, okay, tell me your bank card number, and you can just simply read it off as opposed to pushing buttons, right? The other thing that might be a little bit different is a lot of these systems now do leverage conversational AI because they're much more open-ended, right? So I'm trying to think of who it was recently I talked to, but basically I called into a company and they say, tell me what you want to do, right? They're asking me for the intent. They're using a conversational AI framework that would be pre-programmed in. So if you ask it a question like, well, what's the current mortgage rate? Or I want to buy a house, or I want to save for education, or I want to pay my credit card. That is where you start getting into the conversational AI level, right? So it's not just the straight telephone banking where you're pushing buttons, but when you start talking to the computer, that's where the conversational AI happens. Okay, so as I mentioned, I sort of picked arguably the two most popular frameworks for doing this sort of activity, as well as keeping in mind trying to keep it as easy to use as well. Because, and again, we could do a course completely on each of these platforms. So we are going to look at them in slightly different ways. And the assignments that we're going to do, it's not going to be the exact same on both sides. Even though they are very similar. And I think as you go through them by the end of the course, you're going to see that how you build these type systems in either platform is very similar. The difference is kind of how they go about and how they handle them. Okay, so using Google, their whole Google Voice IVR interaction system is we're using a tool called Dialogflow, and that is how you can essentially create a conversational AI system. And then for Alexa, it's the Alexa Skills Kit. So this is right off Google's website, right? And I love that they're using the term natural language understanding platform, right? So they're really focusing in on that. The Dialogflow platform is about understanding the context of the conversation, right? And in one of the videos that I have you watch this week, there's a good example using Dialogflow where the user wants to book and reserve a meal at a restaurant, and what they do is they simply tell their Google Assistant, "Hey, I want a reservation at this time," and then the assistant responds back, "Okay, I'll do that. If it doesn't work, would this time work?" And then the user responds yes or no if that would work. So you can already sort of see that there is a little bit of intelligence happening where the machine is prompting the user for options and coming up and using some AI to try to develop alternatives. And then it's actually will call the restaurant on the user's behalf and say, "Yes, I have a user that wants to book a reservation for this many people at this time." And again, it's using natural language processing when it's communicating with the individual through a phone. And so here's sort of the developer side of things.
Creating conversational experiences across devices and platforms just got easier. Google Cloud introduces Dialogflow Customer Experience, a powerful new tool for creating advanced virtual agents. Dialogflow CX offers new functionality specifically designed for large-scale implementations. Interactive flow visualizations allow conversation builders to quickly see, understand, and edit their work. A state-based data model allows developers to reuse intents, intuitively define transitions, and handle supplemental questions. In a single virtual agent, separate flows let multiple teams work simultaneously. Plus, there's versioning and environments at the flow level. And you'll have the ability to run A/B experiments and split traffic. Turn any Dialogflow CX agent into an IVR experience with customizable options. Easily assess model performance through the analytics dashboard. Let's kick the tires to see how it works. When you create a new agent, a start flow with welcome intent is provided. Add more flows for more complex agents. You can help customers find out your store location and hours. Start by creating intents for each. Creating an intent is easy. Just add some training phrases. Create the pages and route the matching intents to them. Now you're ready to try it out. A fully functioning bot in under 2 minutes. Engage and delight your customers with virtual agent experiences built using the all-new Dialogflow CX. Come see for yourself. Go online or talk to a Google Cloud representative today.
So I see a few questions there. Can machine-to-machine communicate? Absolutely. You could have AI bot talk to AI. There's actually a lot of work being done. There's a really interesting game I play with my children called Overcooked. And actually this is worth just sidebarring for a second because it's a really cool concept. So what you're doing in this game is basically there's 4 players who are having to prepare dishes based on what the customer orders in the top corner. So one person's going here and grabbing the tomatoes, the mushrooms, the onions. Someone else here is chopping up all this stuff and then dropping it in a saucepan. And then you take it from the saucepan and you put it on a plate and you shove it out to the customer over here. And as the game evolves, the environment changes, right? And it's an extremely interesting game to play with your children because I was always getting yelled at because I wasn't doing something right. But what they're doing is they're actually using this to benchmark now how well different AI systems can work collaboratively to achieve a common goal, right? So you're going to kind of look at this type of AI system in second semester. But this was something that was literally, I just saw it yesterday, that they're using this game as a benchmark for different AI bots to interact with each other. So to bring that back into the conversational space, you absolutely could have one conversational AI bot or agent act on behalf of one person trying to do something, and another AI system that's totally dissimilar trying to interact on the other side. So in the example I talked about earlier, where you're calling a restaurant to book something, sorry, I'm just going to close that. The restaurant could have used an AI system as well to accept bookings, right? So then you could have the Google Assistant AI calling the restaurant booking AI, and the two of them sort of figuring out what they can accommodate. So absolutely machine-to-machine communication. So Alexa is very similar in terms of features and how it behaves. And so you can create a custom skill is what they call it, because Amazon is sort of taking the approach of what you're doing is adding capability or adding skills to Alexa, right? So you could have, so Alexa ask Tide Pooler, so Tide Pooler would be the name of the application for the high tide for today in New York. So then what Alexa's doing is, this is a prime example of what you just asked, is Alexa is asking this application for this information or this question, right? We'll talk about the IoT piece in a second, but it's the exact same thing. Actually right here. So Alexa, turn on the living room lights. So this is the Internet of Things piece where you're using a conversational AI agent to make a request to act on your behalf in the physical world, right? So you're turning on and off lights. And again, this could be a voice system. This could be a scheduled system. This could be a proximity. So, I mean, you could have a system that is smart enough to know, okay, the sun is set. It knows the sun is set based on where it is and time of day. And as you come in to the driveway, or even 5 minutes down the road, the system knows that you are where you are. So it would then turn on the lights, or turn them on automatically. All right. So again, the whole premise behind AI is that you are not pre-programming all of these conditions, all of these parameters. What you're doing is specifying sort of the guidelines or the rules, and then letting the systems or the platforms make the determination of what you're trying to do. In our case, it's generally an audio intent or an audio prompt that's triggering all of these different things. So again, coming back to Internet of Things, what we're talking about is a user asks for something, turn on a light, turn off a light, make me coffee, whatever. And then in the Internet of Things space, we're somehow connecting to a device that then physically does something for us. All right, and then here is a really great video. It's a little bit long, but this is sort of where I was going to wrap up.
Hello everyone, my name is Andrea and I work as a technical evangelist on the Amazon Alexa team. Today, I'm super happy to present to you a series dedicated to building Alexa skills from scratch. It'll be separated into different videos and each video will cover one module independently. If you follow all of these modules together, you'll learn how to build a skill from start to finish. In this first video, we'll cover the very basics, the terminology, a hello world skill, and get you started on the skill building journey. So without further ado, let's get started. So before we get coding, let's look at the fundamentals. What is Alexa? First of all, there's two sides to Alexa. The first side is the Alexa voice service. All you need is a Wi-Fi chip and a microphone, and any device can become Alexa enabled. There's a lot of third-party device manufacturers that are also Alexa enabling their own devices, so it's not just Echoes that can connect to Alexa. The other side to Alexa is the Alexa skill scope. So once Alexa is available through all of these devices, what content do users have access to? And these are skills. Skills are capabilities that developers give Alexa to be able to do different things. So how do you open a skill? You open a skill by first activating the device, and you do that using the wake word, Alexa. Once you open the device, you can open the skill itself. There's various words that you can use, such as open, start, begin, launch. In this case, we're opening a skill called SpaceFax. So Alexa, open SpaceFax. SpaceFax is the invocation name. The invocation name is a name that you decide to give your own skill, which users will need to say in order to open that specific skill. It's okay for it to be multiple words, and it's okay for those words to be generic. A lot of people ask me if invocation names have to be unique. The answer is no. If multiple skills share the same invocation name, it's up to the user to choose which one they want on their Alexa account. But opening a skill is only half of the way. You can definitely open a skill, but sometimes you want to access a specific functionality of the skill using a one-shot utterance. And therefore, you not only open the skill, but you also give a command. So for example, Alexa asks SpaceFax for a fact. Now, for a fact is the utterance. So it is what users can say either when they open the skill or when the skill welcomes them and asks what they want to do. These utterances map to intents. There's various ways of saying the same thing, but all those ways actually mean the same intent. And that is the foundation of building for Alexa. You don't have to worry about specific sentences, you just have to worry about intentions. You as a skill developer decide what intents your skill supports. So for example, giving a fact, or for example, planning a trip, or for example, quitting, or starting a new game, you name it. And you give some example sentences that kind of symbolize this intent. And then it's up to Alexa to route the user in the right intent. So as a developer, you are always working with intents. In this case, we have a get new fact intent, which all sorts of different phrases can trigger, such as tell me a fact, give me a fact, or simply a fact. That would not be enough. Sometimes, if I were to tell you that as a developer you only get the intent that you decide, that would not be enough to satisfy some intents. Because for some intents, the users need to provide extra information. So for example, in this sentence, Alexa asks SpaceFax for a fact about Mars. I'm asking for a specific fact about Mars. And that is called a slot. A slot is the Alexa voice equivalent of a variable. And a variable is a piece of the user's utterance that you need as a developer to fulfill that specific intent. You can have more than one slot in your intents, and users can specify more than one slot in their sentences, in their utterances. In this case, we want to have a slot called planet, because we want to be able to give a fact about a specific planet. Slots can be built in, which Amazon has pre-trained on various models, such as animals, names, cities, or they can be custom and made by you. So, just to recap, we have Alexa, which is the wake word, launch phrase, which can be ask, open, begin, launch, the invocation name, which you decide for your skill, and the utterance. The utterance is what the user says, which maps to a specific intent. And in the case that your intent needs a slot, then that slot will be picked out from the utterance and sent along with the request, which is a JSON request, and we'll look at that later. Now, you can have a lot of basically infinite intents, but there's built-in intents that Amazon provides, and some built-in intents that are mandatory if you want to pass the certification process. And these built-in intents can be help, cancel, stop, but there's also built-in intents like repeat, like shuffle, like get address, right? So these built-in intents are pre-trained on a lot of utterances that help you as a developer not have to input every single possible sentence for very common utterances like yes, no, repeat, shuffle, play, etc. In this case, for example, Amazon.cancel intent maps to cancel, Amazon.help intent maps to I need help, stop to stop, etc. Before we get into the coding, Just to have a very brief overview, there's two sides to building for Alexa. The first side is the voice interaction model. The voice interaction model is where you define your skill name, your invocation name, your intents, your slots, your utterances, basically everything that has to do with the voice interface.
This is really the crux of where I wanted to take things today. Everything he described applies to both the Google platform and Amazon platform. Some of the nuances about how they do this, as well as some of the terminology, is a little bit different. But the core idea is essentially the same.